Okay, so good afternoon po and maraming salamat sa pagsama sa amin sa ngayong hapon sa webinar na ito. So I'm Jeffrey Perez, isa po akong geologist ng PHIVOLCS. And ang gagawin po nating presentation will be very simple. Gusto nating malaman, maintindihan ano nga ba yung banta ng Big One sa Metro Manila at maaaring sa karatig lugar ng Metro Manila. So ang mga kasama po natin dito ay nasa iba't ibang lugar, maaari sa Metro Manila or labas ng Metro Manila. At we want you to imagine what will happen to Metro Manila in case na magkaroon ng isang malakas na lindol. And ang presentation po na to ay pwede nating magamit sa ating mga stakeholders dyan sa kanya-kanya nating mga lugar, sa inyong mga opisina, sa inyong mga condominium units, sa mga homeowners association. Pwede nyo pong gamitin ang presentation na ito. Ito po ay ire-record namin at posibleng ilagay po namin sa aming YouTube channel. At sa pagsagot nyo po ng aming mga evaluation forms, makakakuha din po kayo ng kopya ng aming presentation. So you can use this para po sa inyong sa ating sari-sariling mga companies. So ano nga ba yung banta ng Big One sa Metro Manila? Unang-una, we need to understand na ang Pilipinas ay isang seismically active na country. So ang ibig sabihin ay hindi po katakataka na nagkakaroon ng mga lindol sa Metro Manila at maging sa buong Pilipinas. Yung nakikita po nating mapa sa kanan, yung may red dots, these red dots represents earthquake events in the past 100 years. Kada isang tuldok na nakikita natin ay isang lindol. Sa PHIVOLCS, minomonitor po namin itong mga lindol na to, and every day, we are recording at least 20 earthquakes per day. So ganun po karami ang mga lindol na nare-record ng PHIVOLCS. May mga pagkakataon na kung sakaling may malalakas na lindol, for example, yung nangyari sa Abra last year, may mga events sa may Basco, Batanes na kung minsan nakaka-record kami sa isang araw ng mahigit 1,000 lindol sa isang araw. So hindi katakataka na maraming lindol kasi ang Pilipinas ay parte ng tinatawag na Pacific Ring of Fire. Ang Pacific Ring of Fire, siya po yung boundary ng tinatawag na Pacific Plate. Boundary po siya ng Pacific Ocean na kung saan dito sa Pacific Plate boundary na to or sa Pacific Ring of Fire, maraming mga lindol at nandito rin yung sentro ng mga active volcanoes. So ang Pilipinas, kasama ang Japan, Taiwan, Indonesia, yung North America at yung South America ay kasama or part ng tinatawag na Pacific Ring of Fire. Sa isang araw, at least 20 earthquakes yung nare-record, and sa isang linggo, mga 4 to 5 earthquakes per week yung nararamdaman ng mga tao sa Pilipinas. Hindi naman lahat ng lindol ay nararamdaman, mas marami yung hindi nararamdaman or yung mapaminsala. Pero for the past 400 years, mahigit 100 na yung destructive earthquakes. And at least 10 or 10 of these destructive earthquakes was felt and damaged Metro Manila. Bakit may mga lindol sa Pilipinas? May mga lindol kasi meron tayong tinatawag na mga sources ng earthquakes. Meron tayong earthquake generators na pwede natin silang we can classify this into two. First is yung tinatawag or yung tinatawag nating trenches. These trenches are located offshore of the Philippines. Meron trenches on the eastern side and the western side of the Philippines. On the eastern side, we have the East Luzon Trench and the Philippine Trench. These trenches are the boundaries ng tinatawag na tectonic plates. And along these boundaries, dito sa mga trenches, we can have mga earthquakes offshore. And then on the western side of the Philippines, we have the boundaries of the Eurasian Plate and the Philippine Mobile Belt, wherein the Eurasian Plate is being subducted along the Manila Trench, Negros Sulu Trench, and Cotabato Trench. And since these trenches can generate an earthquake and they are offshore, they can also generate tsunami. And within the Philippine archipelago, you can see here red lines And these red lines are called active faults. So every places or every region, at least every region in the Philippines, except for one province, which is Palawan, have their own active faults. And these active faults can generate earthquakes. And since these active faults are onshore or in islands, mas destructive or mas malakas yung pwede niyang i-generate. For the past 60 years, these are some pictures of recent large earthquakes in the Philippines. One of these was the 1990 Luzon earthquake, a magnitude 7.8 earthquake, which is considered as the most destructive earthquake in Philippine history. This earthquake, if you can remember, damaged many buildings and many buildings in northern and central Luzon. One of these was the Hyatt Hotel in Baguio City. Another significant earthquake was the 1976 magnitude 8.1 Moro Gulf earthquake and tsunami. This is considered as one of the significant because this earthquake killed more than 6,000 people because of a 6-meter high tsunami that inundated areas around Moro Gulf, such as Pagadian City, Zamboanga City, Sultan Kudarat, and Cotabato City. In recent years, we saw the effects of earthquakes in Bohol in 2013 with a magnitude of 7.2, wherein more than 200-year-old churches were damaged by this strong ground shaking. And then we have observed the earthquakes in Mindanao, such as the magnitude 6.7 Surigao earthquake, magnitude 6.5 later earthquake, and the series of earthquakes in Cotabato and Davao del Sur in 2019. Last year, here in Metro Manila, we felt an earthquake wherein the epicenter was in Abra in northern Luzon. So this earthquake was a magnitude 7.0 earthquake. This is the first magnitude 7 earthquake after the 1990 magnitude 7.8 Luzon earthquake. So this is very significant because this is the very first earthquake with a magnitude 7 in northern Luzon after more than 30 years. And these are some pictures of the damages brought about by this magnitude 7 earthquake. If you want to know more about this earthquake, we encourage you to visit or to screen grab this this link so that you can read the impacts and the source fault of this magnitude 7.0 Luzon earthquake. But if we talk about Metro Manila, one of the historical damaging earthquake in Metro Manila was the 1968 Kasiguran, or we call this as the Ruby Tower earthquake. So ano ba yung kwento ng Ruby Tower earthquake? There was a 6-story mixed-use facility or building called Ruby Tower located in Binondo, Manila. After the earthquake, this Ruby Tower, a 6-story residential building, totally collapsed after the earthquake. And this earthquake killed more than 260 people dun lang sa may Ruby Tower and injured another 260 people. What is significant here was that the source of this Kasiguran or Ruby Tower earthquake was not in Metro Manila. The source of the earthquake or the epicenter of the earthquake was in Kasiguran, Aurora. Ang Kasiguran, Aurora is more than 250 kilometers northeast of Metro Manila. So ibig sabihin, malayo yung source ng earthquake, but it damaged buildings not only in Binondo, but also in other parts of Manila. So one of this is the Ruby Tower. If we talk about much more historical earthquakes, you just visit historical churches. And one of these is yung Manila Cathedral. In Manila Cathedral, if you read the historical marker, Manila Cathedral will tell us not only the history of Manila, but it will also tell us history of past earthquakes that affected Manila Cathedral. One of these was written, such as yung partially destroyed by an earthquake of 1600s. And then Manila Cathedral was destroyed again by another earthquake of 1645. The 1645 event, the epicenter of this, based on our research, the epicenter of the 1645 event was in Gabaldon, Nueva Ecija. And then Manila Cathedral was again destroyed by an earthquake of 1863. The epicenter of the 1863 event is offshore of Cavite. So nasa dagat siya. It damaged Manila Cathedral, and there was also reports of 1 to 2 meter high tsunami documented in Intramuros. So hindi lang strong ground shaking, but the 1863 event also generated a tsunami. Remember, hindi po lahat ng buildings ay nasisira in case there will be an earthquake. If you visit another church, this is a church in Makati, yung church of Guadalupe. This church withstood the earthquakes of 1645, 1754, and 1863. So anong ibig sabihin nito? Mayroong malalakas na earthquakes in Metro Manila. Some of these earthquakes damaged Manila Cathedral, but there's no damage in Guadalupe Church. So what's the difference between the Manila Cathedral and Guadalupe Church? The difference here is yung foundation, the location of these two churches. Yung Manila Cathedral, which is located in Manila, these are situated near the Pasig River, near Manila Bay. So ibig sabihin, they are very close to bodies of water wherein yung subsurface are soft compared to Guadalupe Church, which is on the central part of Metro Manila. The subsurface here ay yung tinatawag na adobe. These are volcanic rocks, these are hard rocks, and the importance here is if you take a look at the subsurface of Metro Manila, if you are near Marikina River, Pasig River, malalambot yung mga lugar dyan. They are composed of soft sediments kasi malapit sa ilog, malapit sa dagat. But if you are on the central part of Metro Manila, yung mga may adobe, you are on the harder part, or the subsurface is just is much stiffer compared to areas located along the river, Marikina and Pasig, and along the Manila Bay area. So how do PHIVOLCS monitors this earthquake? So remember, earthquakes cannot be predicted. Hindi siya katulad ng typhoon that they will, Pag-asa will issue information or weather information. They will issue yung kung kailan darating yung bagyo. They will issue the typhoon signal. But for earthquakes, there's still no technology to predict or to forecast kung kailan magkakaroon ng lindol. So what PHIVOLCS is doing is we have installed more than 100 seismic stations strategically located all over the Philippines so that we can monitor earthquakes as low as earthquakes with magnitude 1 up to magnitude 9, magnitude 10, anywhere in the Philippines. Using our seismic stations, we can also monitor earthquakes coming from other countries like in Japan, in South America, we can monitor that. And we can also monitor mga nuclear explosion. So the purpose here is that within 13 minutes, PHIVOLCS will issue an earthquake information. And this earthquake information, pwede nyo siyang puntahan sa website ng PHIVOLCS, phivocs.dost.gov.ph, or you follow us on our official Facebook and Twitter account. Whenever we issue a bulletin or an earthquake information, these are two items that you need to consider. First is yung focus and yung epicenter. Focus is a point inside the earth where the earthquake started. So sa ilalim ng lupa, we have faults and trenches. Kung saan nag-start yung earthquake, we call that as a focus. The point on the surface directly above the focus, yun yung tinatawag na epicenter. So epicenter is much more important to us kasi the closer we are to the epicenter of the earthquake, the higher the intensity na pwede nating maramdaman. So if you are looking or if you're reading the earthquake information of PHIVOLCS, you need to read first yung epicenter, because the closer you are to the epicenter of your earthquake, the higher the intensity na pwede nating maramdaman or naramdaman. And to measure the strength of an earthquake, we are using two terms, yung intensity and magnitude. Intensity and magnitude are two different terms. So dapat hindi natin siya pinagpapalit. Magnitude is based on seismograph. Magnitude is the measure of the total energy release at the earthquake point of origin. So magnitude is the energy of the earthquake. For example, kung i-compare natin sa isang bulb, yung location ng bulb, the location of the bulb is the epicenter, yung wattage is the magnitude, and then the intensity or the brightness of the light is the intensity of the earthquake or yung intensity ng light. So magnitude is just one number. Hindi siya nagpapalit-palit or hindi siya kaiba-iba sa isang lugar. Magnitude is just one number. We use Arabic numbers such as 5.3, 7.2, 7.8. Ang nag-iiba is yung intensity. Intensity is the perceived strength of the earthquake. This is based on what we feel, what we observe. So intensity is a scale used to estimate the effects of an earthquake at a particular site. So ano yung nakikita natin, ano yung nararamdaman natin. This is based on the relative effect to people and structures. Generally, intensity is higher near the epicenter of the earthquake. The closer we are to the epicenter of the earthquake, the higher the intensity. So ibig sabihin, sa isang lindol or sa isang earthquake, there will only be one magnitude. For example, if we relate it to the earthquake last year sa Abra, the magnitude of that earthquake or the epicenter is in Abra. The magnitude of the earthquake was 7.2. This earthquake was felt at intensity 7 in Abra and Ilocos Sur. While here in Metro Manila, we felt that earthquake at intensity 3, intensity 4. Mababa siya kasi we are far from the epicenter of the earthquake. So ano pa yung pwede nating i-consider dito? We also need to consider where we are inside a structure. Normally, buildings na mataas yung floor or higher buildings, yung mga nandun sa taas, they will feel the shaking much stronger compared to people na nasa lower floor ng building. Hindi yan nakakatakot kasi buildings are constructed na kailangan niyang mag-shake. Ang building na hindi nag-shake during the earthquake, mas delikado siya. So, kailangan nating ipaalam sa ating mga stakeholders na if you are in the higher floor ng building, it is normal that you will feel the earthquake stronger compared sa lower part ng building. So, within the building, pwedeng magkakaiba or there will be differences sa intensity na mararamdaman natin. The higher the floor, maybe the higher the intensity ng shaking na mararamdaman natin. In the Philippines, we are using the PHIVOLCS Earthquake Intensity Scale. So yung tinatawag naming PEIS. Intensity, you can describe or you can identify kung anong intensity that you can feel during an earthquake. This scale is 1 to 10, 1 being the lowest and 10 being the highest. From intensity 1, which is scarcely perceptible, to intensity 10, which is completely devastating. We will not discuss this one by one, but I will give you some pointers, and my colleagues here will post a link kung saan nyo pwedeng i-download yung PHIVOLCS Earthquake Intensity Scale. So what is important here? First, yung intensity 1, 2, and 3, these are weak shaking. Malamang yan, we will never feel this earthquake kasi mababa lang siya. At intensity 4, these are generally felt by people indoors and some people outdoors. So pag intensity 4, Mostly nararamdaman siya ng mga taong nasa loob ng building and probably yung mga nasa higher floor ng buildings. Light sleepers are awakened by this earthquake. At intensity 4, the vibration or the shaking is just like merong dumaan na isang maliit na heavy truck sa tabi ninyo in a road. Ganun yung pakiramdam nyo. Hanging objects swing considerably. So parang may dumaan na hangin. And then there you can hear some sounds of yung mga plates natin, mga plato. If there's a swimming pool on your building, pwedeng you can see some oscillation of this water or sa mga drums. At intensity 5, strong, these are generally felt by most people indoors and outdoors. So basically at intensity 5, lahat ng mga tao na nasa loob, inside and outside the building, they will feel the earthquake. So at intensity 5, hindi na tayo nagtatanungan kung may lindol. Posibleng at intensity 4, there will be some questions. May earthquake ba? But if intensity 5, ano na yan, lahat inside and outside of the building or yung mga residential houses natin, we will feel that earthquakes. Many sleeping people are awakened by this strong ground shaking. Hanging objects swing violently. We can also observe shaking of leaves and twigs of the trees. So 5, lahat ng tao nakaramdam. At intensity 6, many people are frightened and some may run outdoors pero wag natin gagawin yan. Some people lose their balances and then heavy objects like furnitures, cabinets, mga monitors natin ng computers at intensity 6 nakikita natin nagsishake na siya. Okay? At 5, lahat ng tao nakaramdam. At 6, yung mga cabinets, electric fans, monitors, chairs, mga stand fans natin at intensity 6 pwedeng nagsishake na siya. Nakikita natin gumagalaw na siya. And at intensity 7, yung kaninang nagsishake, nagda-drop na sila or bumabagsak na sila. So heavy furnitures, heavy objects or furnitures overturn or topple. So mas marami yung natatakot at intensity 7. At intensity 8, it will be very difficult for us to stand during the shaking. So that's the clue here. Pag nahihirapan na tayong tumayo, yung mga gamit natin sa loob ng bahay or offices ay nahulog, that is now intensity 8. Many well-built buildings are considerably damaged because of this very destructive, strong ground shaking. That is intensity 8. And then intensity 9, people are forcibly thrown on the ground. It will be very difficult for us to stand. Mas maraming buildings ang nasisira. And at intensity 10, completely devastating. So, 4, inside the buildings, nararamdaman yung earthquake. Yung nasa labas, pwedeng hindi pa. At intensity 5, people inside and outside the building, naramdaman yung earthquake. Intensity 6, yung mga heavy furnitures, gumagalaw na sila. Pag bumagsak, intensity 7, intensity 8, it will be very difficult for us to stand. Intensity 9, hindi na tayo makatayo sa lakas ng earthquake. Damage to buildings, nagsa-start siya, it will start at intensity 6 pataas. So anong na-observe natin? At intensity 6, we can observe sa mga walls natin, yung mga pader, we can observe hairline cracks. Okay lang yan. Normal lang na makakita tayo ng mga hairline cracks at intensity 6. Buildings, if they follow the building code, if our building was properly designed, properly constructed, may building permit, and we follow the building code, our building can survive intensity 8 earthquake. So ganun lang kasimple. If our building are structurally sound, then magsisimula lang siyang magkaroon ng significant damage at intensity 8. So, as a review, Metro Manila have many earthquake sources. The left map, you can see some red lines here. These red lines are considered active faults. In Sierra Madre, on the eastern side of Metro Manila, you can see these red lines. These red lines are the different segments of the Philippine fault, the longest fault in the Philippines, and some local faults in Rizal area. There's also faults in between Mindoro Island and Batangas area, yung Lubang Fault. And if this fault will move, mararamdaman yan sa Metro Manila. But significant for Metro Manila in terms of the active faults is the Valley Fault System, located on the eastern side of Metro Manila. That's one source of earthquake that will cause significant damage to Metro Manila. Another source of earthquake is the Manila Trench. The Manila Trench is located offshore of Metro Manila. Labas siya ng Manila Bay, around 250 to 300 kilometers away. Nasa West Philippine Sea siya. And this Manila Trench is capable of generating a magnitude 8 plus na lindol. And if that earthquake is more than magnitude 7, it can also generate a tsunami. So, consider these two scenarios. What if gumalaw yung Valley Fault System and the Manila Trench? What will happen to Metro Manila? First, we will expect different earthquake-related hazards. This includes surface faulting, ground shaking or strong ground shaking, liquefaction, earthquake-induced landslide, tsunami, and yung secondary hazard, which is fire. So ground rupture is the creation of the new or renewed movements of old fractures, oftentimes with the two blocks on both sides moving in opposite directions. So simplihan natin. If sa isang lugar, meron siyang active fault, if the active fault gumalaw siya ng more than magnitude 6, shallow, this fault may rupture up to the surface. Pag umabot siya sa surface, it will generate some cracks. And these cracks or rupture, ito na yung magiging source or magkakaroon siya ng fault rupture or surface rupture. Just like what happened during the 1990 Luzon earthquake. So the left photo here is an helicopter shot or an aerial shot of a rice paddies in Nueva Vizcaya. Makikita natin yung crack sa gitna. This crack is the source of the earthquake. This is the surface rupture. This rupture or crack extends for about 120 kilometers. So from Nueva Vizcaya up to Nueva Ecija, that's 120 kilometers. Ang haba niya is just like twice ng South Luzon Expressway. It is much longer compared to the North Luzon Expressway. So ganun kahaba yung rupture. And these rice paddies were displaced by 6 meters. So imagine if you have a structure on top of an active fault na magkakaroon ng surface rupture, that structure will be damaged. Just like what happened during the 2017 Leyte earthquake. So this is the surface rupture. Yung fault traverses this basketball court. It damaged this basketball court. Then it traverses or it damaged this house or this building. Ito yung nakikita natin sa loob ng buildings. All of the structures na nasa ibabaw ng isang surface rupturing earthquake, lahat yan masisira. This is another example of a ground rupture during the 2013 Bohol earthquake. The top photo is a helicopter shot of the surface rupture. This rupture extends for more than 20 kilometers. This part is around 2 kilometers of continuous surface rupture. And then on the ground, kung kanina there's an horizontal movement, here you can see a vertical displacement of the fault. This displacement or vertical displacement is about 1.5 to 2 meters. This house, this nipahat, is less than 10 meters away from the fault. So when we talk to the owner of this house, ang kwento niya, during the earthquake, it was very difficult for her to stand during the strong ground shaking. Ganun kalakas yung lindol. It was an intensity 8 earthquake. So during the earthquake, difficult to stand. So ang ginawa ni nanay is lumuhod na lang siya or bumaba na lang siya because now off balance na siya. Tapos na yung lindol, gumapang siya palabas kasi nahihilo pa siya. And then nagulat siya kasi umangat yung lupa by about 1.5 to 2 meters. Pero mas nagulat siya kasi yung bahay niya ay hindi nasira. So bakit hindi nasira yung bahay? The first reason is the house is not on top of the fault. Imagine if this house is on top of this fault. And then here, yung bahay, yung ginamit na materials are wood and bamboo. During an earthquake, wood and bamboo will just sway during the earthquake. So imagine what will happen to the hollow blocks, concrete na mga bahay natin during a strong ground shaking. So in terms of the effects of ground rupturing, first is yung fissuring. We can see some cracks, and then there will be displacement of the ground due to the movement of the fault. Anything on top of the fault, kung yan ay building or mga structures, it will be damaged because of this ground rupture. There's still no engineering mitigation for surface rupturing effects. So the question is, nasaan ba yung fault sa Metro Manila? The Valley Fault system is composed of two segments. Meron tinatawag na East Valley Fault and the West Valley Fault. East Valley Fault is much shorter, 10 kilometers with a magnitude of 6.2. And this East Valley Fault traverses the municipalities of Rodriguez and San Mateo, Rizal. Hindi ibig sabihin na buong munisipyo, but there are portions or barangays in Rodriguez and San Mateo, Rizal being transected by this East Valley Fault. So nandun siya sa kabilang side ng Marikina River. And then the longer fault, which is the West Valley Fault, 100 kilometers, capable of generating a magnitude 7.2 earthquake. Yung northern end niya is located in Doña Remedios, Trinidad. This is along the within the Angat Reservoir. Hindi tinatamaan yung dam, but it will start on the Angat Reservoir area in Doña Remedios, Trinidad, and it will traverse the easternmost side of Norsagaray and San Jose del Monte. Nandun sa mga bundok sa Norsagaray and San Jose del Monte. Then it will traverse Rodriguez, Rizal, dyan sa may Macabud, dyan sa may Barangay San Jose, malapit dyan sa may Amityville. So mamaya kung maalala ko pa yung ibang mga subdivisions. And then from Rodriguez, Rizal, tatraverse niya yung Quezon City. Sa Quezon City, lalabas siya sa Barangay Payatas, Bagong Silangan, Batasan Hills. So dadaanan niya yung mga subdivisions malapit sa Capitol Hills, Villarreal, Vista Classica. And then from Quezon City, tatawirin niya yung Marikina City. Marikina in barangays Tumana and Barangka, Industrial Valley, the subdivisions, yung Loyola Grand Villas, Loyola Grand Villas, may ibang mga subdivisions diyan. You can check it later on. And then from Marikina City, lalabas siya dito sa may C5 area. Dadaanan niya yung C5, and then from C5 tatawirin niya yung mga subdivisions ng Acropolis, White Plains, Green Meadows, then yung Valle Verde 1, 3, 4, 5, 6, Kawilihan Village. It will cut the Pasig River, then it will go to Makati sa may Comembo, Estrembo, Pembo, Rizal. Then it will traverse yung Taguig. Maraming mga barangay sa Taguig. Almost all of the barangays in Muntinlupa are transected by the West Valley Fault. Then from Muntinlupa, it will traverse San Pedro, Binyan, Santa Rosa, Cabuyao, and Calamba. And then sa Cavite, in Carmona, GMA, and Silang. So If we want to imagine it, magsisimula siya sa Bulacan, sa may part ng Angat Reservoir, and then ang end niya ay lagpas sa may New Valley, sa may Santa Rosa and Calamba, Laguna. So ganun kahaba yung West Valley Fault. Just for you to imagine. This is an aerial shot na ginawa namin. So this is located in Carmona, Cavite. So you can see a feature na ginagamit ng mga geologists. This is a fault scarp in Barangay Lantic, Cavite. This is another shot of this area. May mataas, just like in Bohol, there's a vertical movement of the fault, and you can see a subdivision here, yung Carmona Estates. Here, you can see yung Canyon Ranch. These are areas located in San Pedro, Laguna, 103V subdivision, Barangay San Jose, General Mariano Alvarez. This fault is very close to South Luzon Expressway. So, nandun lang siya sa tabi ng Skyway. This is located in Barangay Tunasan, Muntinlupa. As a reference, this is South Luzon Expressway. Yung red dot is the trace of the fault. From here, this fault traverses this village, this church, Catholic Church, very close to Philippine National Railway and South Luzon Expressway. When we go to Marikina, ito yung dinadaanan ng trace ng fault. You can see some houses transected by the fault. As a reference, this is the Loyola Memorial Park. The good thing here is that because we have the active faults map, yung isang area na dinadevelop nila, kung saan yung trace ng fault, hindi na sila naglagay ng property. They use it as a subsidiary road. So nasa road yung fault. And here is a reference in between Quezon City and Marikina River. So the red line is the location of the fault. If you want to check kung nasaan yung fault, you can visit this, and some local government units have already installed mga markers, mga fault markers. So this is along Ortigas Avenue. As a reference, may overpass. This is Medical City. Yung trace ng fault is on this red circle. So hindi tinatamaan yung hospital, but this fault crosses Ortigas Avenue. As a reference, ito yung marker niya, yung both sides. So idudugtong lang natin, and you can see these markers. This is a marker installed by the Pasig City LGU. This fault traverses major roads such as C5, Ortigas Avenue, and Marcos Highway. It also traverses the South Luzon Expressway. It is near the interchange of Alabang and Susana. Based on our preliminary identification of buildings, there are more than 3,000 structures transected by the Valley Fault System. So what is the issue about the Valley Fault System? What we have done here in PHIVOLCS is we studied this fault. So based on our research, based on our studies, this fault is an active fault. Mainly, it will move horizontal. There is horizontal movement maybe between 2 to 3 meters, and there will be a vertical displacement of about half a meter. Based on paleoseismic studies, this fault has already moved 4 times in the past 1,400 years. Ibig sabihin, the repeatedness or the movement interval or nauulit yung malalakas na earthquake every approximately 400 to 600 years. So ibig sabihin, approximately every 400 to 600 years, there may be a surface rupturing earthquake or malakas na earthquake along the Valley Fault System. And the last major earthquake was 1658. So more than 365 years ago, yung last major earthquake along the Valley Fault System. 365 years is very close to 400. And remember, this is approximately 400. It could be earlier than 400, or it could be
greater than or more than 600 years. So we need to prepare for this. Ang sinasabi natin dito, matagal na siyang hindi gumagalaw, more than 365 years. So it may rupture or it may generate an earthquake within our lifetime or pwede naman sa next generation. But we need to prepare for this. If you want to know the location of the fault, if you want to know the distance of your buildings, of your residential houses, you just visit these two websites, faultfinder.fivox.dost.gov.ph or thehazardhunter.juris.gov.ph. So para lang kayong nagwe-waze, you just look to your house, double click, and then we will tell you how far you are from the trace of the fault. So how to avoid the effects of ground rupture? Avoid constructing a structure on top of an active fault. So we have this zone of avoidance. If you know the trace of the fault, you build your houses or your buildings at least 5 meters away from the trace of the fault or the deformation zone. So kung identify yung trace of the fault, you just measure 5 meters away from the fault on both sides or the edge of deformation zone, then you can build any structures na makaka-survive na isang intensity 8 earthquake. Because if you are not on top of the fault, all of the residents in Metro Manila, including Cavite, Bulacan, Rizal, Cavite, Laguna, and the rest of Central and Southern Luzon will feel a very strong ground shaking. The ground shaking is the disruptive up and down and sideways vibration during a ground shaking. So kahit na wala tayo dun sa fault, if we are in Metro Manila, pwede nating maramdaman yung strong ground shaking. Gaya nga ng sinabi ni Doc Toto, earthquakes don't kill, buildings do. So the ground shaking effects includes damage or collapse of structures, or it may consequently cause hazards such as liquefaction or earthquake-induced landslides. Tandaan, earthquakes don't kill, buildings do. In the Philippines, we have the National Building Code. Ang sinasabi sa National Building Code, sisimplihan natin, if we follow the National Building Code, our buildings can survive an intensity 8 earthquake. So what we have done in FIVOX is to simulate. What if magkaroon ng earthquake along the West Valley Fault? Let's say half of the West Valley Fault or the entire Valley Fault system, the whole Metro Manila, parts of Cavite, Rizal, Laguna, and Bulacan will experience intensity 8 ground shaking. So ibig sabihin, buong Metro Manila will feel this kind of ground shaking yung nasa video. So in our preparedness, we need to prepare for an intensity 8 nag-earthquake. Very strong ground shaking. Ito yung pwedeng maramdaman natin. Based on a study conducted in 2004 by FIVOX, JICA, and MMDA, yung MMRers, more than 38% of residential buildings will suffer damage because of this strong ground shaking. 38% of the 10 to 30-story buildings, and then there could be a human loss of more than 33,000 with more than 100,000 of seriously injured and pwedeng magkaroon ng sunog. So this is a study in 2004. And remember, hindi siya masyadong sinasabi, but this scenario is a nighttime scenario. So what we have done is yung mga tao nasa loob ng bahay, and then we shake Metro Manila on computer, and then we found these numbers, and this is a nighttime scenario. This study was in 2004, so we have updated this number. In 2016, ito na yung computation natin. Actually, mas tumaas yung number of fatalities because of the increase in population. So based on the calculation in 2016, more than 34,000 fatalities in Metro Manila alone, Bulacan more than 2,000, Rizal more than 3,000, and the total is more than 48,000 fatalities with very serious injury of about 24,000. So we need to prepare for this strong ground shaking. In areas na very close to river system like Marikina and Pasig River, and areas along the reclamation area there, reclaim areas along the Manila Bay, Rojas Boulevard area, very close to Manila or Manila Bay, these areas are prone to liquefaction. So ibig sabihin, because of their closeness to bodies of water, the sediments are very soft. It is very easy to shake. So nagkakaroon ng liquefaction. So this is a phenomenon wherein sediments, especially near bodies of water, behave like liquids similar to quicksand. Madali siyang alugin. And the effects here is sinking and tilting of structures, sandballs, and fissuring and lateral spread. So just like this one, because of the strong ground shaking, the building will not collapse, but it will sink, magtitilt siya. So if sa ground shaking, we need to follow the building code. Here in liquefaction, we need to have a proper foundation. And we have also identified number of buildings that could be directly affected by liquefaction. So there will be more than 568,000 structures that are within the liquefaction-prone area in Metro Manila. There could also be landslides in Metro Manila. Saan pwedeng magkaroon ng landslides? Dito sa may Quezon City Park, yung mga steep slopes dyan sa may Payatas area, Batasan area. These are areas prone to landslide. In Makati, sa may C5, corner Kalayaan Avenue. These are also steep slopes or steep areas. These are prone to landslides. If you go to Muntinlupa area sa may bandang Alabang, may mga road cuts dyan na pwedeng magkaroon ng earthquake-induced landslides. So these are downslope movements of rock, salt, and other debris commonly triggered by strong ground shaking. And areas along the Manila Bay, Parañaque, Malabon, Navotas, Manila area, these areas are prone to tsunami. So tsunami are sea waves, small to large, resulting from disturbance of seawater by undersea earthquakes, landslides, volcanic eruptions, and meteor impacts. So tatandaan natin, lahat ng coastal areas sa Pilipinas ay tsunami prone. So anywhere in the Philippines, lahat ng pinupuntahan nating dagat or beach resorts, these are all prone to tsunami. And in the case of Metro Manila, if there will be a movement along the Manila Trench, let's say a magnitude 8.3 earthquake, the tsunami in Manila Bay will arrive around 45 minutes to 1 hour. And then the height of tsunami is around 3.5 meters. So more than one floor ng building. Pag high tide, magdadagdag siya ng 2 meters, around 2 floors of a building, 5.5 meters. And then the inundation is about 2.7 kilometers. The right map is a hazard map. These are areas that will be inundated by tsunami. So if you want to have these maps, you just visit hazardhunter.juris.gov.ph. And since we have many developments and communities in Manila Bay, there are more than 299 structures prone to tsunami, and the estimated population is more than 2.5 million. And after a strong ground shaking, there will be damages on our lifeline. Pwedeng mawala ng kuryente, water supply, telecommunication, and there we will also expect damages to our roads, collapsed bridges, and damages to our ports. So the main challenge to us is how do we save the lives of more than 26 million people in GMMA or the Greater Metro Manila area? How do we make our critical infrastructure resilient? We will answer that later. How do we ensure the continuity of the government, business, critical public services post-earthquake? How do we ensure the financial resiliency of GMMA? And in your case, how do you ensure the continuity of your services in your stakeholders? How do we safeguard our national security post-disaster? And how do we do all of the above urgently, effectively, and full-time? So maraming salamat po.